What we're going to do is look at key aspects of graphs. We've done a few of these with domain and range. We're going to add a couple more to our arsenal. First thing is our Y-intercept. Our Y-intercept is where it crosses our Y-axis. So right here would be our Y-intercept. That would be the ordered pair 0, -2. The next one would be our zeros, our roots. This is our X-intercepts. So in this case, we have two X-intercepts. We have -2, 0, and we have 2, 0. Our maximum is our highest point of the graph, and our minimum is our lowest point of the graph. So in this case, there is no maximum, and there is a minimum. Our minimum right here is the ordered pair 0, -2. Now notice that some points are both aspects, the y-intercept and the minimum in this case. So just because a point may be not just considered one thing, it may be considered multiple things. So looking at our first example, what we have is our y-intercept. So when we're looking at this, y-intercept is where it crosses our y-axis. So it crosses the point at 0, 2. Zeros or roots are x-intercepts. So in this case, it would be -3, 0, and we have 1, 0. Our maximum is our highest point. We actually have a maximum here. That would be -1 and 3. Just in case you weren't sure, we're going to the left 1, we're going up 3. That's how we're coming up with the ordered pair. The minimum would be none because it keeps on going down. Our domain, this is what we're going off of the past couple days. Our domain is going to be our x values. So it goes to the left from this arrow, it goes to the right. So that would be -infinity to infinity. Now, if you like set notation better than interval notation, you're welcome to use that. It doesn't matter. So x and then XER. Some students prefer one more than the other one. Either one is fine. Our range would be our y values. So this is our highest point at 3. It's going down. Remember, we do the least value first, and then we do the greatest value. Or we could do the set notation where we say y such that y is less than or equal to 3. And then, is it a function? We talked about this a little while ago. Function would be every x only has one y. We draw our vertical line test, and we see that it just crosses once, so it is a function, yes. Let's look at another example. This time, our y-intercept, if we're looking at it, is where it crosses the y-axis. Notice it crosses twice. It crosses at 0, 1. It also crosses at 0 and 3. Our zeros, roots, or x-intercepts, that's where it crosses the x-axis, 1, 2, 3, 4. So that right there would be 4, 0. Our maximum, notice that it keeps on going up, so that would be none. And then our minimum, it keeps on going down, so that would also be none. If we're looking at our domain would be going to the left. It stops right here. So that right there would be -3. So I have a bracket at -3 and it's going to infinity. Or remember, what we could do is we could go x such that x is greater than or equal to -3. And then for our range, if we're looking at our range, it's going up, it's going down. So it would be -infinity to infinity. Or what we would do is we would go y such that y, e, r. Y is an element of real numbers. Is it a function? Well, to determine if it's a function, we draw the vertical line test. We see that it crosses twice. So no, it is not a function. Now what we're going to do is we're going to look at some more summer packet stuff. This is finding square roots. The square root of 4 is 2, and the reason why is because 2 times 2 gives us 4. So it's the opposite of squaring something. 2 squared is 4, so the square root of 4 is 2. The square root of 0 is 0. The square root of 49 is 7. 3 times 7 gives us 21. The square root of 100 is 10, but because of the negative, that would be negative 10. And the square root of 16 is 4, but we have 3 squared, which is 9. 9 times 4 gives us 36.